guys, welcome to my channel. Today we're going over Leetcode 540 question, a single element in a sorted array. So you're given a sorted array consisting of all the integers where every element appears exactly twice, except for one element which appears exactly once. Find the single element that appeared only once. So 2 is the only single element, others are all duplicates, so you output 2. And 10 is the only single element and every other has a duplicate. So your solution should run in log n time. So this is an important note because if you're familiar with coding in Python, you should know that there is a built-in function called collections.counter, basically creating a dictionary out of the list, and the dictionary's keys are the numbers and the values of the key of the dictionary are the frequencies. However, you basically just have to return the number when the frequency is 1. However, creating a dictionary or creating a collection.counter dictionary costs O(n) time, so it doesn't satisfy our requirement. So log n time is a big hint for doing this problem in binary search. Plus, this is like a sorted array, so this is another major hint for doing this problem in binary search. The problem or the question is, if we're doing in binary search, how do we conduct the binary search? So if we get our middle point in this 3, and we find that 3 does have a duplicates in the array, how do we chop the left part or the right part off? So this is our question, right? So to solve it in binary search, you have to make important observation. Let me put it here. So this is our example 1. So if our example 1 doesn't have any single element, so all the element or duplicate numbers, we can see that all the even index position and the element next to the even index position are the same number. So let me just put the index here. 3, 4, 5, 6, 7. So you can see that all the index position numbers equal to the number next to it. So this is when there is no single element in the array. If there is a single element in the array, let me just add the 2. So if there is a single element, then we can see that it's our old rule that all the even index position is equal to the element next to it doesn't exist because we inserted this single element in the array. However, all the elements before the single elements still has the rule that the even index number is equal to the number next to it. So that is an important observation because if we check all the even index positions and find out it is different than the number next to it, then we will know that the single element must appear before the even index position or is at the even index position. If we find that the even index position and the number next to it is equal, it means that the single number must appear after this index, right? So this is basically our idea. So let me just try to code it up and hopefully you can understand it better. So our low will initialize to 0 because we're searching from the 0's position. Our high will be length of nums minus 1. So search from 0 position all the way till the end, right? And for binary search, there is like a template for you to write, right? Well, low, smaller than high. Then we calculate our midpoint. So the midpoint is left plus right mod divided by 2. This is an integer division, right? So we don't want to get any like digit numbers. So this is our integer division. However, if we just calculate our mid by adding left plus right and divided by 2, we can get like even and odd indexes. But in our previous observation, we always check the even index position. So how do we get around that, right? So our mid always has to be an even number. So there is a trick, that is you can divide left plus right by 4 first, and you have 2 times this number. So this is basically just left plus right divided by 2, right? This is simple math. However, if you do that, you can see that this number can actually be an even number or an odd number. However, an even number times 2 is an even number, and an odd number times 2 is also an even number. So our mid, if we calculate it like this, it will always be an even number. Yeah, so this is maybe the most important trick in our problem. So after we get our mid, then we just check the number at the mid, if it's equal to the numbers next to it, right? If it's equal, meaning that so this part, the left part,